Welcome to Algeomulus Prep Academy. Today's lesson is the integration of the 6 basic trig functions.
These are the integrals of the 6 basic trig functions. The integration of sine u du equals negative cosine u plus c. The integration of cosine u du equals sine u plus c. The integration of tangent u du equals negative ln the absolute value of cosine u plus c. The integration of cotangent u du equals ln the absolute value of sine u plus c. The integration of secant u du equals ln the absolute value of secant u plus tangent u plus c. And the integration of cosecant u du, which equals negative ln the absolute value of cosecant u plus cotangent u plus c.
Our first example is the integral of tangent 6 theta d theta. First, use u substitution. We are going to set u equal to 6 theta. Derived, this will make du equal to 6 d theta. Now replace 6 theta with u, since they are equal. In order to replace d theta with du, we need a 6. However, the equation must stay the same. We can add a 6 on the integral as long as we can put the fraction 1 over 6 on the outside. Now use basic trig identity of tangent u du to solve. Bring down the 1 over 6 and integrate the function tangent u du. Replace u with 6 theta. Add the variable c to the function, which represents a constant. And there is your answer.
Example number 2. This integral problem includes 2 trig identities. We will use both formulas for secant u and cosecant u to solve the problem. The trig identities are the integration of secant u du, which equals ln of absolute value of secant u plus tangent u plus c, and the integration of cosecant u du, which equals negative ln absolute value of cosecant u plus cotangent u plus c. Use u substitution by setting u equal to 2x. Solve for du, which is 2dx. We can separate the trig because they're being added together, and this will make it easier to integrate later on. Now plug in u and du into the function. For du, we need 2 times dx. We can add a 2 if we multiply the integral by 1/2, which allows the function to stay the same. 1/2 times 2 is equal to 1, so we're allowed to multiply the function by this because we're not changing it. You will then get the 1/2 the integration of secant u du plus 1/2 the integration of cosecant u du. Integrate the functions using the trig identity formula. This will then get you 1/2 times ln, the absolute value of secant u plus tangent u plus c1, plus 1/2 times negative ln, the absolute value of cosecant u plus cotangent u plus c2. Don't forget to multiply each one by the constant 1/2. Then replace the u's in the function with what we set u equal to, which is 2x. Distribute the 1/2 and simplify. The constants c1 and c2 add to make c. Your final answer then will be 1/2 ln the absolute value of secant 2x plus tangent 2x minus 1/2 ln cosecant 2x plus cotangent 2x plus c.
For the third example, we are going to evaluate the integral 1 over x to the 4th power minus 6 root x plus 5 cotangent x dx. You can simplify the integral by bringing up x to the 4th, which becomes x to the negative 4, and expressing the square root of negative 6 root x as an exponent. Recall that the integral of cotangent u du equals ln absolute value sine u plus c. We can now begin to integrate. Recall that the integral of x to a certain power where the power cannot equal negative 1 is equal to x to a certain power plus 1 over the power plus 1. So, integrating x to the negative 4th power yields x to the negative third power over negative 3. Integrating negative 6x to the 1/2 power yields negative 6x to the 3/2 power over 3/2. Plug in ln absolute value of sine x plus c for cotangent x, which yields 5 ln absolute value sine x plus c. We can further simplify our answer by bringing down x to the negative third power, which becomes negative 1 over 3x cubed. We can also multiply 2 to the numerator and denominator of negative 6x to the 3/2 power over 3/2 to yield negative 12 root x cubed over 3. This gives us the answer negative 1 over 3x cubed minus 12 root x cubed over 3 plus 5 ln absolute value of sine x plus c.
Our next example is integral of parentheses x plus 1 multiplied by cosine x squared plus 2x plus 4, all added to sine 2x. Our first step is to separate the integral into two separate integrals. Next, we will establish the u's for u substitution. There will be two separate u's, because we have two separate integrals. The u for the first integral is x squared plus 2x plus 4, because it is the inside function. du1 is the derivative of u, equal to 2x plus 2 dx. The u for the second integral is 2x, and du2 is 2 dx. Now we want everything in terms of u. To do this, we will substitute our u's and du's. Notice that to achieve our du's, we must multiply the integrals by 2. However, we cannot actually change the integrals, so we will multiply by 1/2, since 2 times 1/2 is 1. Now we can integrate. Remember that the integral sine u du is equal to negative cosine u plus c, and integral cosine u du is equal to sine u plus c. Notice that since we are adding two integrals together, there are two unknown constants, c1 and c2. Since we have integrated, we can substitute back our u's. Since c1 and c2 are both unknown constants, we can add them together as one unknown number c. And that is your answer.
Thanks for watching Algeomulus Prep Academy. Like and subscribe for other helpful math videos.